Hi folks, welcome back. I hope you're all doing well. The paper I'm looking at today was published back in 2021, but I really wish I'd come across it sooner. The problem the authors are looking at is the classic one of using LLMs to answer long-form questions and doing it with retrieval of documents that are then used to ground the answer to that question. This is the standard retrieval augmented generation design pattern. And that's exactly what they do. They take a benchmark, they design an LLM-based question answering system, and they ace the benchmark. Now, at this point, they would have been justified in declaring victory, but the authors go much, much further than that. The bulk of this paper is actually about the many confounding problems which make this seeming achievement not look so impressive anymore. And that is the really impressive part of this paper. The authors really dig much further than just an impressive benchmark result and try to break the result, as it were. And they uncover some really interesting problems that anyone who's designing a retrieval augmented system with LLMs will have to tackle when building and deploying such systems in the real world. So, not to bury the lead, the three main problems they found were, first of all, the generated answers were not actually grounded in the retrieved documents. Now, that's a fairly fundamental problem. The second one is more of a problem with the benchmark, which is this particular benchmark had a lot of overlap between the training and the validation set. The third problem is with the measure that the benchmark uses. Now, you'll see a lot of LLM question answering benchmarks use a metric called Rouge L. Roughly speaking, the Rouge L measure looks at the longest common sequence of words between the generated answer and the golden known good answer. And the authors point out that that's not such a great metric by which to be judging systems like this. So let's start by looking at the benchmark that they were tackling. They were looking at the Eli 5 benchmark, Explain It Like I'm 5, which is based on the subreddit of the same name. And this benchmark asks the model to generate paragraph length answers to fairly open-ended questions. The example they use here is, how do jellyfish function without brains or a nervous system? Now, if you look at some of the largest models around, they will already have a lot of world knowledge in their pre-training set. But even so, if you give them external documents at retrieval and generation time to augment their intrinsic model knowledge, you'll get better answers. This data set has about 272,000 training examples, with about 1,500 used for validation and 600 as test examples. So the authors built their own RAG LLM system. They trained their own retriever and own LLM for generating answers, and they end up acing this benchmark. But when they dig deeper, the first fundamental question to ask is, are the generated answers actually grounded in the retrieved documents? And they find that not to be the case. Now you might ask, how did they test for that? What they did was take randomly sampled paragraphs from Wikipedia as input for the generation. And when they compared it with their predicted generation, which used the proper retriever, they find barely any difference in the scores. So that's pretty strong evidence that the quality of the retriever almost did not matter at all. And most of the success of the answers is coming from the model's built-in pre-trained knowledge. But just to get extra validation, they even ran some human evaluations where human volunteers were asked to choose which of these two answers, the one with the predicted proper retrieved documents or the one with random paragraphs from Wikipedia? Which of those two answers was better? And the human volunteers most of the time were unable to clearly pick one set of answers over the other. And while this paper is looking specifically at the Eli 5 benchmark, they found that this is a more general problem. Other benchmarks suffer from this issue as well. This raises two other questions. The first one is, well, if the retrieved documents don't really help generation, how does this model end up doing so well? And that is because of the way they've trained this model. It prefers predicting long sequences. It was partly trained on Project Gutenberg. And the hypothesis is that these long generations help the Rouge L scores. But then where are the answers coming from? They're coming from the inbuilt weights in the model, and how did the model get them in the first place? And the answer to that is that there's a lot of overlap between the training and validation data sets of this Eli 5 benchmark. And this is a problem that's happening with a lot of other benchmarks as well. This problem is quite severe. They found that 81% of the validation questions had at least some part of their input paraphrased in the training set as well. So basically your model is just getting these answers from its training set. The second systemic problem that the authors point out is that Rouge L is not a great metric for benchmarks like this. And the way they go about demonstrating that is by trying to find upper and lower bounds on Rouge L for this kind of benchmark. If you really messed up your answers, what's the lowest score you could get? And to find a lower bound, they do something nonsensical like copy the question 5 times, concatenate it, and retrieve a random training set as answer. So that's an intentionally ill-constructed answer. And for the upper bound, they simply take Rouge L of the golden known good answers themselves. And what they found was that the lower bound is competitive with some of the other leaders on that benchmark, and the upper bound, which is the score of the golden answers, is actually worse than some of the leaders on the benchmark. So this then is pretty damning evidence that Rouge L is not a great benchmark because it can't differentiate between valid and invalid answers. So where does that leave us? The authors end up recommending basically using human evaluation to judge the performance of a system on benchmarks. But that is not an easy thing to do. It's expensive. Humans themselves have a difficult time evaluating the quality of these answers. They might be unfamiliar with the topics that these questions and answers are about. The answers are long. They take time to read. They need a lot of concentration to judge the quality of. But at the end of the day, what the authors are saying is, yes, human evaluation is challenging, but if you really want to get a sense of how your retrieval augmented LLM system is doing, you've got to do human evaluation. So that was a quick look at a paper which talks about some of the real world challenges in constructing long form question answering systems with retrieval and LLMs. If you like content like this, please like the video, consider subscribing, and I will see you all next time. Thank you very much.